are not the teacher. You do not get to tell people what to do. Stop talking, both of you. Do you want a write-up? Because I have no issue with that. I'm going to put the warm-up on the screen so you guys can get going on it. It should not take you very long. And then we will get going on what we're doing today. All right, I'm going to give you guys about 5-7 minutes-ish. I'm going to use the quadrant on the right. So what quadrant would -4, 7 be located in? Number 2, what letter is located at -5, -1? Number 3, what ordered pair describes E? And the bottom one, don't know what it says. I think it says the absolute value of something. There it goes. The absolute value of -91. What is the ordered pair? Yeah. Yeah. Yeah, you can log in if you need to be able to see it better. Yep.
I'm done.
I just wanted to let you know there will be inside recess today. The fields are too wet, so plan on staying inside. And we will be having bus evacuation drills at 12:30 today, teachers. So right after lunch, there should be 12 buses here so that each class can go on one bus. That way we can still stay socially distant. But you'll need to take your jackets with you because it will be cold outside. So we will begin calling classes down about 12:30. Thank you. Have a good day.
That's what I was just going to push science back probably a half hour just in case. I'll talk about that in a minute though. Okay, we'll do about 2 more minutes on this warm up and then we will go over it. I get that you might be done already, but it's tight. Some people are joining late, so. Or haven't even attempted it. Okay, let's go ahead and go over it. So, I'm going to go ahead and stop sharing. And then can we see the board behind me pretty good?
Yeah.
All right. So I redrew our picture up here, right? Coordinate plane, and kind of wrote the questions down so we can go over them. The first one asks us what quadrant is negative 4, 7 in. Before we do that, let's label the quadrants. Where's quadrant 1? Top right is quadrant 1. Where's quadrant 2?
Top left.
Top left is quadrant 2. Quadrant 3?
It's the bottom left.
Bottom left. And where's quadrant 4?
Bottom right.
Bottom. There's only one left, right? That's quadrant 4. So if we're plotting the point negative 4, 7, where does that go? Quadrant 2. So you start at 0, 0, you go backwards 4, up 7, it's somewhere up here. That means it's in quadrant 2. Okay? How'd you guys do on that one? Good? Pretty good? Good. This question is going to be asked a lot this week. So keep this in mind, what quadrant is where and how you find that, okay? Number 2, what letter is at negative 5, negative 1? B. So you start here and you go backwards 5, down 1. Point B. How'd you do now? Good? Good, good. All right. 3. We need to figure out the ordered pair for E. Where is that?
Negative 1, 1.
Good. Backwards 1, up 1. So negative 1, positive 1. Oops. I think it's because you wanted to answer the question, which you did. So it's good. And then our last one doesn't have to do with the quadrant plane. No, what I meant, coordinate plane. Whew. How do I find the absolute value of negative 91?
The absolute value of 91 is 91.
Good.
Negative 91 is 91.
Good. You just take the number that's inside, whether it's negative or positive, and make it positive. So it's just 91. Done. How'd you guys do on all of those?
I got 4 out of 4.
4 out of 4? Good. That one wasn't too difficult, I think. A lot of this top part, 1, 2, and 3, is similar to what we're going to do this week. So we're going to do quite a bit of stuff with that, okay? So let's see if it's posted. We have a set of notes we're going to go over. It's not too interactive today. I'm going to be asking you guys questions about it, but we're not necessarily going to type on it very much until later, okay? Not posted yet? Okay, I'll make sure. We're going to go get it posted. Under math. Okay. That's going to get posted, so reload your page and open it up, please. Hello. Yes, they did.
They moved the cold Sandra.
Huh?
When they called in for the evacuation,
Well, they said they're going to get 12 buses, and there's 12 classrooms. So I think, yeah, I'm pretty sure we're all going to get our own bus. So, they might call us one by one just so that it's not a huge rush in the hallways. So I think it'll go pretty quick, actually. Yeah. Is it all posted?
Yeah.
Okay. So it is called Reflections on a Coordinate Plane Notes. So you guys can go ahead and get that opened up. It's yeah. It's kind of a long set of slides. Kind of. We can. But the best way to do this presentation is in present view. You can't really just look at the slides. You want to click through them. So I'm going to present the screen, like present it, so that when we click through it, we can go over it before it gives you answers. It's not the greatest of PowerPoints, but it's a good one to start off with the concept. But we are going to be doing reflections on a coordinate plane. Because if you look at this coordinate plane, right, we could split this directly in half and draw something on this side that would reflect exactly the same on this side. Yeah, kind of. So we're going to talk about how to take like this point B and reflect it so that it is also over here, and how to do that, how to change the order pairs so it works, and stuff like that. So I'm going to sit down because I don't need to stand this whole time. And where are you going? Okay, this won't hide. There we go. All right. First of all, take a look at these ordered pairs. Okay. We have 4, 3, negative 7, 2, negative 6, 1, and 3, 5. When you're looking at ordered pairs, which one is your X and which one is your Y?
The one on the left is the X, and the one on the right is the Y.
Good. So your first one, so 4, negative 7, negative 6, 3, those are your X coordinates. It's your horizontal movement. That means that the other one, the second number in your ordered pair, 3, 2, negative 1, negative 5, is your Y coordinate. Okay, so X is always first. It's alphabetical order. So X first, then Y. Okay. It says take the opposite of the X coordinates. So what's the opposite of a positive 4? Negative 4. So we would make the first one negative 4, 3. We've taken the opposite of the negative, or the 4, made it negative. Someone tell me what the opposite of, oh man, it did it already. Never mind. The next one is 7. The opposite of negative 7 is positive 7. What about the opposite of negative 6? That becomes positive 6. What about the opposite of positive 3? Negative 3. So if we look at all of those, all we've done is change the X coordinate. Have we done anything to the Y coordinate at all? Nope. Okay. Well, now the arrows go.
Hi.
Hello. But ask, what are some differences between the ordered pairs? Which we just did that. What did we take the difference of? What did we do? We changed the X coordinates first. Okay. What stayed the same? The Y coordinates. Okay. When we do this, that means that we are taking an ordered pair and reflecting it over the Y axis. Now keep in mind that the X axis is your horizontal one, the one that's side to side, and your Y axis is the up and down one, your vertical axis, okay? In order to to reflect, oh my gosh, there it goes. Okay, Y axis. In order to reflect something over the Y axis, you change the X coordinate. So it's like an opposite reaction. Okay, so to reflect something from this left side, sorry, that's the right side over here, you change the first number, the X coordinate, so that it flips across the X or the Y axis and ends up on the other side. So if we were to, it does look like a happy face. If we were to take the opposite of positive 2, what does it become? Negative 2. So our new ordered pair would be negative 2, 4, because all we've done is flipped it over the Y axis. You just changed the X coordinate. Kind of see how that works? When we change the Y coordinate, it reflects it down or up. It'll do the opposite reflection. So if you're reflecting over the Y axis, change the X coordinate. It's opposite. Okay? So let's do that a couple more times. There's your smiley face too. So our next one is at 6, negative 1. What coordinate am I going to change to flip it over that Y axis?
You're going to have to make them both negative.
Well, negative 1 is already negative. It stays the same.
Well, you're going to have to change 6 to negative.
Good. All you do is change your first number. This positive 6 becomes what? Negative 6. So negative 6, negative 1 flips all the way across to the other side. So if we were to fold this coordinate plane in half, those points would go on top of each other. Okay, it's a reflection across the axis. So, negative 6, negative 1. All we've done is change the X coordinate. Okay, look at another one. 3, 5. Positive 3, positive 5. Which coordinate am I going to change, the 3 or the 5?
You're going to have to change the 3.
The 3. Our positive 3 is going to become what? Negative 3. That's going to flip it across to the next one. Yeah, that's why I said we have to do it in presentation view so that you can click through it. If it's in presentation view, you'll be able to click through it so it doesn't show you the answers right away. Kind of like how I'm doing it up here. So in this case, we've taken the opposite of your x-coordinate and it flips it over the y-axis. Okay? We can do this a couple more times. Honestly, we can do it forever. This time we're at -4, 0, which is on the horizontal axis, but that doesn't matter. If I take the opposite of my x-coordinate, what's my x-coordinate in this one?
-4.
So our x-coordinate is -4. I'm going to flip it over the y-axis. What does the -4 become?
Changes to the normal 4.
Good. Changes to a +4, and it flips across the axis. This is making a little bit of sense. You're just changing one thing from positive to negative or negative to positive, and it flips the whole coordinate across the axis. Makes it a reflection. Okay?
I'm getting it.
Good. Good, I'm glad. Tomorrow we're going to do a more interactive one where you guys are going to be typing into it. Today is not super interactive. I'm sorry. Let's look at another one. -3, +6 is up there near that. Which one am I going to change? The -3 or the 6?
You're going to change the
The -3. Good. What does it become? +3.
I like how it makes a smiley face.
It does just make a smiley face. So our new ordered pair is +3, +6. It is a weird looking smiley face. I like the ones that are really long and far
I like
apart.
the ones that are short and their eyes are like
Shorten like this. Yeah. Okay, let's see. I don't know how many examples there are, but we're just gonna keep going. I think there's a few more. Our next order pair is -1. Oh man, -1, -3. In order to flip it across the y-axis, what will I do?
You're gonna have to change the you're gonna have to change the -1 and you're gonna change -1 and put it to
Good. So in order to do that, we change the x-coordinate, which is the -1. -1 becomes +1. And you end up at +1, -3. That one's a tiny smiley face. It's a cute little one. All right. Do we need to do more? I don't want to do that one. Okay, let's do this check for understanding, okay? So on slide number 10, this is where you are going to type a little bit of information. We're going to answer these 3 questions together on slide number 10. Okay, slide number 10 says when you reflect ordered pairs across the y-axis, which coordinate stays the same? The x or the y stays the same? The y stays the same. Y coordinate stays the same. Okay, so the second number in your ordered pair stays the same if you're reflecting across the y-axis. I'll like highlight this or something so it's a little bit easier to see. Yeah, your y coordinate will stay the same.
the next one.
It will be. The next one, which coordinate changes?
The x coordinate.
The x coordinate. Good. If your x coordinate changes on this one. Basically, yeah. Our next one, why do we think it works that way?
I don't know.
Why do you think you only change the x coordinate? So it's reflecting it, and it's also staying on the same horizontal line if you do that. Your y value stays the same, so you're always going up or down the same amount. It's just changing the side-to-side movement, right? So, gotta. It basically just causes the point to reflect over the y-axis without changing the up or down movement of your point. Yeah. So it takes the ordered pair and it reflects it on the horizontal line. So it's not changing its up and down movement at all. It just keeps it on the same side to side movement, just opposite. Okay. I'll give you a minute to go ahead and write that down. I know, there's a lot of slides.
Are we doing them all today?
Yeah, I believe so. Most of them are just like, we just did like 6 examples in like 3 minutes though, of the other one. Mm-hmm. I'm going to give you about 1 more minute to get this typed out, and then we're going to go back to the presentation view and go through what happens if you need to reflect it over the x-axis. Okay, so we've been talking about the y-axis so far. Now we got to talk about the other one. All right, you ready? Okay, let's go ahead and keep going. So I'm going to present it again just so that we're back in this view. And we're going to go to the next slide. Again, we're going to look at the ordered pairs and talk about how to reflect over the x-axis this time. Yep, we're just taking the opposite again. So instead of reflecting it over the up and down axis, we're going to talk about it reflecting over our horizontal one, our x-axis.
Wait, so does the x-axis always stay the same?
What do you mean?
Like on this, does it always stay the same?
If you're trying to reflect it over the x-axis, the x-coordinate stays the same and the y-coordinate changes.
So if you're reflecting it on the y-axis.
Mm-hmm. So on this one, we need to take the opposite of the y-coordinates. Is that the first number in our ordered pair or the second one? The second number. So in our first one, 4, 3, what does that ordered pair become? 4, negative 3. We take the opposite of our positive 3 and make it negative. Okay, what about negative 7, 2? What does that become? Negative 7, negative 2. So our first number stays the same. We change our second number. What about 6, negative 1? Sorry, negative 6, negative 1. Good. Our negative 6 stays the same. And then our negative 1 changes to positive 1. And then finally, 3, negative 5. Good. The 3 stays the same. The negative 5 becomes positive. So just like before, the difference is which coordinate. Or, yeah. The y-coordinate, it changes. That's our difference. And then what stays the same? The x-coordinate. Good. So this time we're reflecting it across the x-axis. We're going from either the top, reflecting it to the bottom, or we're taking it from the bottom and reflecting it up to the top. Okay? So, good. Our first pair, 1, 2. Over 1, up 2. Which number am I going to change, the 1 or the 2? The 2 on this one. What does it become? Negative 2. So our ordered pair changes from positive 1, positive 2 to positive 1, negative 2. And we get some sideways smiley faces this time. Okay? Do you guys see the difference there? We're just changing the other coordinate this time. Okay? Let's do it again. We're at 5, 6. What changes? The 6. What does it become? Negative 6. So over 5, down 6 makes it a really long sideways smile. Right? Notice that they're on the same up and down line still. The the x doesn't change. It always moves over 5. It's just now gone down instead of up, right? Our next one, 6, 4. What changes? The 4. What does it become? Negative 4. Get a nice little smiley face. Is this making some sense though? The opposite way? Okay, what about online? How are we doing online?
I'm doing good.
Doing good? Hopefully the rest of you guys are too. Okay. Just got really busy. Our next one. Is that Mr. Jordan?
Yeah, I heard it.
Oh. All right. Our next one, -4, 1. What is going to change? The 1. What does it become? -1. So it's going to do a tiny little smiley face over to -4, -1. Okay. All right. Couple more. Our next one is -2, -3. What changes? The -3. What does it become? +3. So it flips up to -2, +3. Okay. One more, and then we'll go answer some questions. We're at 4, -6. What changes? The -6. What does it become? +6. So it flips all the way up to the top at 4, 6. Okay.
The next one is one of those questions.
Yeah, we're going to skip the question mark one. Okay, let's go ahead and do these check for understandings on this. We're on slide number 19. Okay, slide 19. When you reflect ordered pairs across the x-axis, which coordinate stays the same? If you reflect it over the x coordinate stays the same. Okay, so our x coordinate stays the same on these ones. All right. So if the x coordinate is staying the same, which coordinate changes? The y coordinate. Good. The computer's being very slow right now. There we go. Okay. And then why does it work that way?
Because they're reflecting on a vertical line.
Yeah, we're trying to reflect it on a vertical line, so we have to change the y coordinate. It's hard to type when I'm sitting on this. Okay. So we're reflecting it on a vertical line, so we have to change the y coordinate to make it go the opposite direction, up or down. Okay. We're almost done. A few more minutes. Huh.
Is this all we're doing here today?
Yeah.
Oh, that's it.
What? Well, we'll get there in a second.
We had a lot.
Okay, I'm going to give you a minute to go ahead and get that typed out.
So, you know, we did in fourth grade. So we did, we had to draw our names, and we did our names symmetrically. And what we did, we had to make a picture out of it. And I made a drawing.
All right. Let's go ahead and look at the next step. Let me look ahead because I'm pretty sure. Let's see what the next part is. Determine if the following slides have true reflections or false reflections over the x or the y axis. So we need to decide if they have done it correctly or not. Okay. So our first one looks like this. They have reflected it over the x-axis. Is that true? Did they reflect it over the x-axis?
Yeah.
Remember, the x-axis is horizontal, and you changed the y-coordinate. So did they change our +4 to a -4?
Yeah.
Yep. So is this a good reflection or a bad reflection? It's good. This one is a true reflection. They did it correctly. Okay?
Like, how come they show the check mark for the?
Check mark means true. They did it correct.
Okay, that's why you have to do it.
That's why I'm doing the present part. Yeah. If you're just looking at the slide, it's going to tell you already. I'm going to keep it in present mode, just so that we can check it ourselves. So, our next one. Did they reflect this one over the x-axis?
No.
It went from -3, -2 to 2, -3. So there's two things wrong with this. Which axis did they reflect it over?
Why?
They reflected it over the y. But did they even do that correctly? No. How do we know they didn't do that correctly?
Because it's not even like
Good. It's not even lined up on the same horizontal line. So that they even reflected over the y-axis wrong if they did it. If they were trying to do that. So this is true or false? Way false. They did two things wrong here. Wrong axis and just the wrong reflection in general, right? Okay, let's look at our next one. Oh, I went too far. That's okay. This next one is at 1, 3, and they reflected it to 1, -4.
Oh, that one was the same.
It looks like it's correct, but why is it not?
Because it has a 4 and no, because it's what?
Yeah, there's two things. Both of you guys are correct. First of all, it wants them to reflect it over the y-axis. Which one did they reflect it over? They reflected it over the x-axis.
Oh, wait, so it wants to go vertical. It wants it to go
Yeah. So they took it from the top and moved it to the bottom, which was the wrong axis. They wanted it to be from the right, reflected over to the left. Okay? If it had asked us to reflect it over the x-axis, it still would have been wrong though. Why?
Because it's not even equal.
It's on a different coordinate. This one is over 1 up 3. So this should have been over 1 down 3. But they put it at 1 -4, which is too far down. So overall, just wrong, right? Not correct. How many are there of these? I don't even know. Yeah, go ahead. Let's just do one more. This one we're reflecting over the y-axis, -2, 0. First of all, did it get reflected over the y-axis? Did it go from left to right? Yes, no, maybe so?
Yes.
It did on this one. It's on the axis if you can't see it. Starts off right here and goes over to this one. Did it go to the correct spot?
Yeah.
It did. You would change your x-coordinate. This -2 becomes a +2. Becomes 2, 0. That is a true one. I don't really want to do 8 of these, so let me look ahead. Yeah, that's okay. I think we're good. That actually is the last of it. We don't need to answer these questions. We are going to do a little bit more with this tomorrow where you guys will actually be typing things out and doing some work on your own with some guided help. So it won't be as boring tomorrow, I promise. But once you're done, you can get it turned in. Those of you that are online, give me a second to take attendance. And also, I want to talk to you about science today, so don't leave, please. Let me just take attendance. It was Jada and Juliana. So they don't really necessarily need to be logged in. Yeah. Okay, got attendance. Now, so for science today, I'm going to push it back a half hour. So instead of having science start at 12:30 today, it's going to start at 1 o'clock and go until 2 o'clock. We have at the school, we have bus evacuations. We have to do like that stuff where we go to the bus. They talk about what you're supposed to do if something happens on the bus, and then they make us get off the bus in weird ways. So we have to go do that at 12:30, which means we are not going to be here to do our live lessons. So that means we're going to do our lesson at 1 o'clock today for science instead of 12:30. Does that make sense? Sound good? Hopefully.
That sounds fine.
All right. I don't know. I don't remember. So, that is actually all we're doing for math today. We'll do a little bit more with that tomorrow. More